Good morning. This is part 2 of the solutions to the odd number problems from the test we just recently took. This is the page 2 uh, file. Okay. Now this is how the second page of the test looked like. Now this is too small for us to actually be using, so I will be zooming in onto individual problems. Okay, the problem number 13 is, you should realize right away that this is a two-step problem. We have, we need to solve for a letter n equals question mark. So what is being done to it? Two things. We have an operation over here plus an operation over here. So that's why it makes it a two-step problem. I will delete. Okay, the very first thing you want to focus is on this. It's not the 5, it's not the -1, it's not this or this, it is this. We want to get rid of that first. And I'll erase all this. How do we get rid of the +2? Well, by subtracting 2, doing the operation that's opposite of what's being done. So -2 to both sides. We have to do the same thing to both sides of the equation. So what's left on this side? Well, the +2 minus 2 cancel away, it's 0. What's left is just this. And out of n over 5, there's the equal sign. And what is this equal to? -1 minus 2 is -3. Make sure you don't put a -1 or 1. Make sure you're fully, you're pretty good at addition and subtraction of positive and negative numbers. Anyway, at this point, the problem becomes a one-step problem. We need to get rid of this 5. How do we get rid of the 5? What's 5 doing to n? It is dividing n. Therefore, in order to undo it, we need to multiply by 5. And as soon as I do this, I have to do the same thing to the other side. 5 multiply. Now, again, the reason I put parentheses in there, just so it's not confusing with that negative sign. If I only have -3, but it was just regular 3, +3, I would just write 5 times 3 without parentheses. Okay, anyway, so what's this 5 and on the right-hand side? What are the 5s going to do to each other? They're going to cancel out, and what's left is simply n by itself. Now, what's on the left-hand side is 5 times -3 is -15. And you're done. Yeah, n is by itself, and regular numbers are on the other side. So that's what we want. So make sure you put a box around it to let me know that that's your final answer, because it is, again, it's very confusing if you put all that work, and I really can't tell what your answer is. It's very hard for me to give you partial credit or full credit, even if the work maybe itself is correct. Alright, I'm not going to do problem 14, but looking at it, it is exactly, the skill-wise, it is exactly the same as problem 13. Alright, I'm going to jump to what we call, in this particular case, we're translating word expressions into a math equation. Now, this is like a very, very basic word problem, even though it's really not a real-life word problem, but it's translating what the operations are. Okay, the very first one, 10 more than. So the question is, well, what is more than? What operation is that? Obviously, I should say obviously, it is a plus. So 10 more than n. In other words, you start with 10. I'm sorry, I rephrase it. You start with letter n, some number n, and 10 more than that, you add 10 to it. That's what 10 more than n means. And the word is in mathematics, it's the same thing as equals 18. And how do we solve now? This is a one-step problem. How do we solve the one-step problem with a +10 there? By subtracting 10 from both sides. Again, I'm not focusing on the other side. I don't care what's on this side yet. 18 or whatever, I don't care. I need to get rid of this. So I'll put a summation bar. The +10 or +10 minus 10 will cancel out. That's 0. So what's left is n. The equal sign drops down. 18 minus 10 is 8. Very straightforward, very simple problem. Okay, put a box around it, you're done. Now, question is on number 17. The confusing word for some of you may be the quotient. What does the quotient mean? What operation? Well, the quotient is the result of a division problem. So, so what we're saying is x and 4, in other words, x divided by 4. So one way to write this, a more mature mathematical way of writing this, is x with like a fraction bar divided by 4. You know what, it's kind of a little messy. Let me do x divided by 4 is equal, well, there's the equal to 40. Very easy problem, because now how do we get rid of that 4? Well, to get rid of the 4, I don't care about the 40. It's the 4 that's the problem for me. How do I get rid of something that's being divided by 4? I need to multiply by 4. And again, it's both sides, so 4 times the left side, and the right hand side is being multiplied by 4 in order to keep the equal sign valid. Alright, so what happens to this 4 and the denominator 4? They cancel out. In other words, 4 divided by 4 is 1. We don't need to write 1 times x. The answer is just simply x equals, and in this case 40 times 4 is 160. Are we done? Yes, we are. X is by itself, that's what we want. And there's the answer. Okay, problems 16 and 18 are very, very similar. Again, you focus on the wording more than, and number 18, the word is quotient. Okay, I'm jumping to the next set of problems. The product, problem number 19. The word product, what does this mean, product? What operation? It is a multiplication. So the product of y, you have y multiplied, you could put a little x. I prefer to put a big, a dot. At this point you should be comfortable with either one. Y times 11 is the equivalent of equals 32. Okay, I didn't realize that this problem is going to be a fractional answer. Alright, but it doesn't matter. The skills are identical. We need to get rid of this. We need to get rid of the 11, not 32, 11. Another one way to rewrite that is simply write 11 y equals 32. It doesn't really matter. I should be able to be comfortable with both, y times 11 or 11y. Alright, we want to get rid of that 11 by doing what to it? By dividing by 11. Therefore, we have to divide the other side by 11. What's going to happen to my 11s? It goes away with this one. What's left is simply y. The equal sign drops down. And if you leave the answers 32 over 11, I will accept that. Although I would prefer for you, just to use another skill that we've had before, convert it to a mixed number. Question is how many whole times does 11 go into 32? It goes into whole times, and with the remainder going to becoming the numerator, it is 10. On the y space 10, and the 11 remains as a denominator, and there is my answer. Now, most of the problems were set up not to give you a fractional answer, because really I'm testing the skill of solving an equation, and you should be confident. You should be able to do it with both mixed numbers, fractions, decimals. It doesn't matter, but in this particular case, I guess it did the answer was a fractional answer. All right, number 21 is, well, the word is less than. The wording less than mean. What does that mean? It's a minus. It's a subtraction. Now, this is a little tricky for a lot of students. You typically, by reading that, you just want to write down 17 minus q. That is not right. We've covered this before. Make sure you don't do that. Less than Q, what the problem is really saying is you're starting with letter Q, variable amount of Q, and you're taking 17 less, so minus 17. And I always use the example of, if I have, $5 less than you, do I say, and you have, let's say, $100. Do I say 5 minus 100? No, I take your number less, the second one, 100 minus 5 to get 95. Anyway, so this is Q minus 17 equals, this is a really simple problem, is 17. Okay. Okay, so make sure that these two 17s are really not confusing. The second 17, this 17 is that. This 17 is really this. Okay, just by coincidence, the computer generated both numbers being 17, but that doesn't matter. Had this number been, like, say, 20, well, that's what the second part of the equation, that number goes there. Anyway, how do I solve this? Well, if I'm taking 17 away from something, in order to get rid of it, to reverse it, I have to add 17. And I'm adding 17 to both sides to keep the equality valid. And this minus 17 and plus 17 will cancel each other out. What remains is just Q equals, and what is 17 plus 17 is 34. So in some ways this is a good problem, the fact that both were 17s, to make sure that you don't fall for a trap and say, oh, well, the answer has to be 0 because they're both 17. Now you have to read the problem much more careful and don't just jump to the conclusion, but actually set up the equation and show me the work. The whole exercise about this is really showing me that you can do the steps. Not that you can do this mentally, because mentally you can do it on an easy problem, but anytime you have a 2 or 3 step problem, it's very difficult to do it mentally. Okay, let me jump to extra credit. Not everybody's going to get to it, but in this particular case, this is a really easy problem. We are, and I gave you a clue here, we are really, one of the things you look for is to combine like terms. Well, in number 23, I have some v's here, and I have some v's here. I can't have that. I need v equals something like that. In other words, all the v's to one side, all the numbers to the other side, and combine and simplify. Well, in order for me to, let me erase this little thing. Okay. In order for me to get rid of this 3v, I have to subtract 3v from it. As soon as I do this, I subtract 3v from the other side. And I try to line them up so it's easy to see what's going to combine together. Now, at the same time, in the same step, I should be able to get rid of this 9. I realize that I want numbers to the other side. So how do I get rid of a 9? Well, I subtract 9. Therefore, I have to do the same thing to the other side. And I'll put a summation bar. In between that, there's an equal sign. So let's simplify it. Let's use blue. The 9 and the minus 9 will cancel each other out. How about on the other side? 3v minus 3v. Well, that's going to be 0, so we don't need to worry about that. And what else is left? Well, 4v minus 3v, right there, 4v minus 3v is just plain old v. That already simplified for us. Without with coefficient of 1s, that makes it a little easier. And what's the other side simplified to? 6 minus 9 is negative 3. Okay, there's my answer. I box it and I'm done. Had this answer come up with a different coefficient in front of v instead of 1, I would simply divide both sides by that coefficient, regardless of what it is. And I would simplify the other side, and I have my v equals to something. Alright, I will actually do 24, even though I wasn't going to do only odd ones. But I wanted to show you what the skill here is. The skill here is a combination of distributive property and combining like terms. So in order for us to get rid of these parentheses, we really can't do it what's inside the parentheses. We can't simplify it any further, because I have a variable and I have a plain number. Same thing, a plain number and a variable. In other words, constant and something with a variable. I really can't simplify it. The only skill I could do here, as the first step, is distributive property. In other words, this is a multiplication to here and a multiplication to here. Same thing here. This multiplication to here and multiplication to here. When I get rid of the parentheses, I'm going to do this relatively quick. Hopefully you can stay with me. Okay, so 2 times negative 2 is negative 4x. 2 times 6 is 12, so it's plus 12. We still have this minus 4x. We just write it down. Equals, well, you still have this negative x right here. I haven't done anything to it, so it's negative x. This is a little tricky. Make sure you keep track of the signs. So it's really minus 2 or negative 2 times negative 3 is positive 6. And then minus 2 times 4x is minus or negative 8x. Now we need to simplify things. We combine this with this, combine this with this, and I'm going to rewrite this. So what's negative 4x minus 4x? It's really minus 8x. Well, I haven't done anything to the 12 yet, so I'll write plus 12 equals, what's negative x minus 8x is negative 9x, and plus 6, I haven't done anything to 6. Alright, now I need to get everything to one side. Get all my x's variables to one side and regular numbers to the other side. With a little practice, I could tell that it makes sense to add 9 to both sides instead of adding 8 to get rid of it there. So, but if you were to do it the other way, you still have one extra step later on to divide by negative 1 to get rid of the negative, but you should be able to do it anyway. So let me just so in order for me to get rid of this, I add 9x to this side. The effect is I'm really bringing this 9x to the other side. That's what I'm doing. I also want to get rid of the positive 12 by subtracting 12 from this side. So it's minus 12 from this side to keep the balance. Put 2 bars to kind of indicate that you're doing the summation. And let me change the color. What is negative 8x plus 9x? Well, that's just regular x, not 1x. This canceled out. Negative 9x plus 9x canceled out. Equal sign drops. And what's 6 minus 12? It is negative 6. In this case, actually was, again, we ended up with a situation where the coefficient of x is 1, which we don't need to worry about at this point. The answer is x equals negative 6. Had I had some kind of coefficient in front of, let's say, negative 3 in front of x, I would have to divide both sides by this coefficient. But since I don't want to complicate things too much, I'll just get rid of it. Okay, and there's the answer.